These are solving equations involving logarithms. So we have two types, equation type 1, equation type 2. Type 1 has a log equals some kind of a number, or a bunch of logs equals some kind of number. But basically there's something in there, a term, that is not a logarithm. Where in equation type 2, they're all logarithms. So let's look at type 1 first. So with type 1, what we're just going to use is our basic formula. Base, exponent, result. So it's 2 to the power of 3 equals x plus 1. So once you have a log equals a number, we can just rewrite it as an exponential and then solve it. Once we get that answer, we plug it in to make sure it works. So let's try this. This would be a base of 5 to the power of negative 2 equals x. And then we can just simplify it. So we know it's a denominator because it's a negative, and then 5 squared is 25. And that's it. So this would be 2 to the x equals 32. And then now we can go back and use our change of base formula, where we make the bases the same and then set the exponents equal. So a base here would be 2. And so the exponents would be x, and then 2 to the power of 5. And if we check it by plugging in the calculator, it works. So x equals 5. That's it. It's nice and clean. Well, what if it doesn't have a base? Well, that means it's a 10. So this would be 10 to the power of 3 equals negative x minus 2. And that would be 3 zeros. And we can just solve. Plus 2, plus 2. So x is negative 1002. That's it. So again, we still want to check this by plugging it in, make sure it works, but we're good. Okay, on this one, the logs are not together, so we need to put them together. And we're using our exponent rules for sum and difference, our logarithm rules for sum or difference. So if we're adding, we put them together as a multiplication. If they're subtraction, they're a division. And so this is a multiplication. So this would now be 2 to the 5 equals x squared plus 4x. So that's 32. Since you have an x squared, you want to set it equal to 0. And factor. So this is x plus 8, x minus 4. And then we solve it and get x equals negative 8 and x equals 4. Now we have to go back and check all of these answers to make sure that they work. Because what happens is, remember, with domains of logarithms, you cannot have negatives or zeros within the logarithm. So we have to make sure that none of these give us a negative inside the logarithm. So when we plug it in, we get 1 over 25. And we do know 5 to the negative 2 is 1 over 25. This one we don't have to worry about. Negative 1002, so when we plug it in, I'll do it in green to check. Log base 10. The negative of negative 1002 minus 2, and that's supposed to equal 3. So that's positive 1002 minus 2 is 1000. And then is 10 to the power of 3 1000? Yes, it is. Now let's check these. So we're going to plug in negative 8 first. And you can already see that doesn't work. So you have to cross it off. See, the reason is we have a negative and a negative in this one, and we're multiplying them together. So a negative times a negative would turn it positive, so it would work for this situation, but not for our original equation. Now let's check the 4 and make sure it works. So that's log base 2 of 4 plus log base 2 of 8 equals 5. So we're good. And you plug them in, they work. So it's log base 2 of 32. And 2 to the 5 is 32. It checks out. So 4 is our answer. And that's what we do when we have one log or a bunch of logs and a number. So now what do you do when they're all logarithms? So same basic idea. We want to combine them. And in this situation, we're getting a comparison. So it's sort of like this. If the bases are the same, then the exponents are equal. So on this one, if we have logs and logs, then the insides have to be equal. So once we say that, we can solve it, and you get an answer. But after checking it, it doesn't work because negative 2 plus 1 is negative. Doesn't work, so no solution. If it did work, we'd circle it and we have an answer. So let's try this one. We put them together. And since it's minus, it's going to be a division. We have that. And 3. So since the logs have the same base and they are both logarithms, we can say that the insides are equal. I'm going to put a 1 under it, and this will allow us to cross multiply. So we get x plus 5 equals 3x minus 1. And just keep solving. So minus x plus 3 plus 3, divide by 2, and we get 4. Now we still need to check it by plugging it back in. So we get log base 2 of 4 plus 5 minus log base 2 of 4 minus 1. We still want to check it just to make sure we have it correct. So even though we can see they're positives, we want to make sure we have the right answer. So log base 2 of 9 minus log base 2 of 3 is log base 2 of 3. Okay, and then we can use our division. 9 divided by 3. So log base 2 of 3 is log base 2 of 3. It checks out. So our answer is 4. And that's what we do with logarithms. So we have the two types. If it's just a log equals a number, or a bunch of logs equals a number, or there's a random number in there, then we make them into one logarithm so that we can rewrite it as an exponential and solve. And then make sure you check them, especially when you have this situation where we're multiplying them together or dividing, because negatives divided by negatives will turn positives, which will make it work for this situation, but not the original. And if you have all logarithms, we combine them all together to get a nice comparison. So we can say the insides are equal, solve it, get an answer, and check. And that's it.